Okay, you are welcome. This is a question on cone. Now the question says a cone with base radius 3.5 centimeter and height 10 centimeter is formed from the sector of a circle. So we have to calculate the angle of that sector. Okay, this cone is actually formed from the sector of a circle. So if I draw a sector is a part or a region of a circle bounded by two radii and an arc. So something like this. Okay, this is a sector. A sector has a radius. Let's use big R to represent that. Then it also has the angle at the center, and that's what we are required to find. Let's call that theta. Okay, so when this sector is folded, it forms something like this, the cone. Okay, it forms a cone. Now you then agree with me that it is this arc of this sector that actually forms the circumference of the base of the cone. And this radius of this sector is the slant height of the cone. Okay, so I can write that the R here is equal to the L. Is equal to the L here. So at the same time, I can as well write that the length of arc. So let me call this one AB. Length of arc AB is equal to the circumference of the base of the cone. Circumference of the base of the cone. Now let's say this is the radius of the base of the cone. Let's use small r to represent that. All right. So I can relate the two shapes now. This is a plane shape. This is a solid shape. Okay. Now the length of an arc can be calculated using theta over 360 times 2 pi r. So let's use this big R now. That's the radius of the sector. All right. So this is equal to the circumference of the base of the cone, and the circumference of a circle is 2 pi r, as you all know. So we have 2 pi the small r. So if I relate this now, okay, I can get a formula for calculating the radius of the sector, or the radius, this small r, the radius of the base of the cone. Okay, from here I can cancel these two out of it. Can, because this an equation. So what is here is here. So I can cancel them out. This is pi. This is pi. You will now realize that this r, this small r here, that is the radius of the base of the cone, can be calculated using the product of theta and r, and over what? Over 360. What we have to find now is this theta, the theta. So for us to get the theta, it means we need the radius of the base of the cone. And of course, that one is given. Then we need the radius of the sector. And don't forget that according to what I wrote here, the radius of the sector is the same thing as the length, the slant height of the cone. So it means if I can get the slant height of the cone, that is also the radius of the sector. Of course, if I bring out this cone, you realize that I can get the slant height. Okay, let me just try and draw it somewhere here. Okay, let me draw it here. Okay, this is radius of the base of the cone, and that is given as 3.5. That's 3.5 centimeters. 3.5 centimeters. The height, that is the perpendicular height, is given as 10 centimeters. So with this now, the perpendicular height, it means this line forms 90 degrees with the radius. So with this information, I can get the slant height using Pythagoras theorem. So using Pythagoras theorem now, then this is the hypotenuse. So using Pythagoras theorem, we have L square is equal to 10 square plus 3.5 3.5 square. 3.5 square. Of course, my L square will now give me 100 plus 3.5 square. Of course, you have to multiply that 3.5 two times. You have 3.5 times 3.5. Okay, this without wasting time. So this will give me 5 times 5 times 5, that's 25. Okay, we have 5 remainder 2. Remainder 2, 5 times 3, that's a 15, plus 2, that's 17. 3 times 5 is 15, 5 remainder 1. 3 times 3 is 9, plus 1, that's 10. So eventually we have this. So 22. I'm only showing you this so that you know how to go about doing it. So we have 22.25. So L square will give me 100 plus this will give me 122.25. Then you have L square to be equal to the square root 122. Before looking for this, 122.25. When you take the square root of both sides, okay, then L will now give me the square root of 122.25. Okay, I'll continue from next video.